This video is about arithmetic sequences. There are two major types of sequences that we're going to look at in greater depth in this class, and those are an arithmetic and a geometric sequence. So I put an example of each so you can try to figure out what the major difference is between an arithmetic and a geometric sequence. If you're trying to look for the pattern, you'll see that in an arithmetic sequence, there's a certain constant that's being added each term to get the next term. And if you look at a geometric sequence and try to find the pattern, you might recognize that there's a constant that's being multiplied by each term to get the next term. So that's the major difference between arithmetic and geometric sequences. In this lesson, we're just going to dive into the arithmetic ones. So here's the definition: that in an arithmetic sequence, you can find each term by adding or subtracting a constant. I prefer to think about it as just adding, like you're either adding a positive or you're adding a negative each time. So here are 4 examples of arithmetic sequences. So see if you can figure out what the common difference is each time. In this one, you should be able to tell that you're adding 2 each time, adding a positive 2. In this one, it looks like we're adding a half each time, right? To get from 3 to 3.5 to 4 and so on, we're adding a 0.5 each time. In this one, we're adding a negative. So first example where we're adding a negative, and it looks like it's going down by 3 each time, so we're adding a negative 3. And in this last one, it looks like we're subtracting or adding a negative, if you'd like to think about it that way, a negative 10th each time, right? So we're adding negative 0.1. You can always write a recursive definition for arithmetic sequences. So if you remember from our first lesson, a recursive definition is just a formula that bases each term on the term that came before it. So you can see the first one is written as u sub n equals u sub n minus 1 plus 2, which means to get any term, you do the previous term plus 2. And then I put a little note here that said, can you come up with the others on this page? I know you could. We'll just do one example. So this one would be like, to get any term, so u sub n, you would do u sub n minus 1, which means the previous term, and then subtract 3, right? Because the difference each time was a negative 3. So the constant that is added or subtracted each time is called the common difference. You heard me say it, but here you should define it. And the variable that we use for that in the formula is typically d. And in the formula booklet, you'll see that they use d for common difference. So the recursive definition in just formula form is u sub n equals u sub n minus 1 plus d. And of course, if d is negative, then you can just write that as minus d. So d is the common difference, and the recursive definition is pretty easy to come up with, but it's also not that useful because it requires you to know the previous term to get the next term. Instead, the more useful definition is the explicit one. So arithmetic sequences can also be explicitly defined, and if you remember what an explicit definition is, this is how you would just plug in a number to get any term. So I could plug in 50 if I wanted the 50th term, right? And I don't need to know the term that comes before it. So I don't need to know the 49th term. I can just get the 50th term by plugging in 50 for n. So the formula for this is u sub n equals u sub 1. And it's important to just make sure you know what that means, right? That is the value of the first term, right? U sub 1 would be the value of the first term. Plus parentheses n minus 1, which n, of course, stands for the term you're trying to find, the term number that you're trying to find. And then multiplied by d, which is our common difference. This is the formula that gets used a lot on IB exam. It's in the formula booklet. It's much more common than the recursive definition. So this is the one that you're going to end up practicing a lot in your homework assignments and on review sheets and stuff. So let's do an example or two. We're going to find the nth and the 50th terms of this sequence. So when it says find the nth term, that really is just a fancy way of saying fill in a formula. And then to find the 50th term, we'll actually use that formula and plug in 50. So to find the nth term, it really just means write down the formula first. And I always recommend that you just write down the formula without changing a thing. Sometimes you can earn partial credit just for showing that you knew which formula you were supposed to use, even if you stopped here and didn't fill it in. In this sequence, what we're looking at, 2, 11, 20, 29, 38, and so on, we can fill in u sub 1 because that's the first term, right? And we know that the first term here is 2. And we can fill in d, which is the common difference. You should be able to see the common difference just by looking at an arithmetic sequence. If you ever have a hard time figuring out the D, you can always just take any term and subtract the one that came before it. So for example, I could take 29, I could subtract 20, and then I could figure out that D is 9. But you could probably figure out that D was 9 just by looking at it. So then I'm going to fill in the first term, and I'm going to fill in the D. Notice I'm leaving n as n because it wants me to find the nth term. So basically that just means find a formula in terms of n, so you can just leave n as n, so that you could then come along and plug something in. It's good to get in the habit of simplifying, so I could technically stop here. This is the formula that I would use for this sequence, but I like to simplify. So that 9 that's over here normally would be written in front of the parentheses, right? And what it means is it's going to get distributed to both of these terms. So the next thing I did was distribute that 9 and then look for like terms to combine. So this is the simplified version of the formula for this sequence. So then if I wanted to find the 50th term, I have a formula I can plug right into. You could plug right into this step. Often they don't ask you to find the nth term first. So often you'll just be starting with basically this step. So you'll see I plug 50 right into that, but it really doesn't matter. You can plug it into either the unsimplified version or the simplified version. Plugging 50 in for n because I'm looking for the 50th term, and then I'm simplifying it and I'm using my calculator to get some of the more complicated numbers there. So the 50th term is 443. All right, this example asks us, here's a new sequence. It asks us to find the recursive and the explicit forms of the definition, and then to calculate the value of the 25th term. It wants us to write the recursive formula and the explicit formula for this sequence. So I'm starting with the recursive formula, which as I said is not that common, but easy enough to figure out. So this means to find any term, we're going to do the previous term plus D. The only thing I can really fill in when I'm looking at the formula then, or looking at the sequence, sorry, is the D. I can figure out what my common difference is and fill that in. Looks like my sequence is decreasing by 5 each time, so my common difference is -5, and that's it. That's the recursive formula. Because in order to get any term, you plug in the term that came before it. So we need to leave those as variables, u sub n and u sub n minus 1. The explicit definition, we have to plug in 2 values. Just like on the previous example, we switch colors here. We're going to fill in u sub 1, which is the first term, and we're going to fill in d, because those are the 2 things we can tell from looking at this sequence. So I fill in u sub 1, which is first term, 13, and I fill in the d, which is -5, the common difference. And then again, I'm going to simplify this. It's good to get in the habit of simplifying it. So here's my formula for this sequence, the explicit formula. So I can plug in any number to figure out whatever term I'm asked to find. It does ask us to find the 25th term. I'm going to plug in 25. This time, just for the sake of illustrating it, I'm plugging it into the simplified version. You'd get the same thing if you plugged it into the unsimplified version there or the simplified version here. So I'm plugging 25 in, evaluating it using a calculator. Actually, these numbers aren't that big. You could do this without a calculator. But the 25th value of the 25th term is -107 for this sequence. And it's good to check if your answer actually makes sense. I mean, if you look up at the sequence again, does it make sense that 25 terms later that it would be at -107? And that does seem pretty reasonable. Okay, a couple more examples here. Find the definition for the arithmetic sequence whose first term is 5 and fifth term is 11. Now this is interesting because it gives us slightly different information. It doesn't give us the sequence listed out. It only gives us the first term, which is helpful to know because at least I can fill that into the formula. And it gives us the fifth term. It could give us the fifth term, the eighth term, like any other random term, instead of giving us the first, second, third, fourth, in a list. So it's going to give us the first term and one other random term. I'm going to start with the formula, the explicit definition of an arithmetic sequence. When in doubt, just start with this formula and see what you have that you can fill into it. You may find that it's not what you need to use in the end, but it's a good place to start if you're not sure where else to start. So it's an arithmetic sequence. If you forget the formula, you can always look it up in the book. It's written down as the formula for an arithmetic sequence. You write it down and see what we can fill in. I know u sub 1, right? Tells me what the first term is. What I don't know this time is D. I don't know the common difference because I don't know what the second term is, so I can't figure out what's being added each time. But what I can do is fill in this information, that the fifth term is 11. Well, first let me fill in that u sub 1. Like I said, the first thing I know is that the first term is 5. The other piece of information I have is that the fifth term is 11. That means when I'm looking at term number 5, the value of the term is 11. So this is where it gets a little tricky for people. I'm going to put the 5 and the 11 into this formula. And notice where I'm putting them. The n is the term number, and the u sub n is the term value. So it's really important that you note in this formula, right? This is the term number. This n over here is which term you're looking at, right? Term number 8, term number 5, term number 31, or whatever, term number. And this is the term value. Okay, so the value of the term. Sorry about the handwriting. Again, I'm writing with the mouse. All right, once I've got that filled in, now you'll see the only variable that I have in my formula is d. So I'll be able to solve this equation to find d just by simplifying. So you can either distribute the d, or you could simplify what's in the parentheses first. However you get there, you're going to solve the equation for d, and it comes out to 3 over 2. Now I know that the common difference here is 3 over 2, or 1.5. So with a common difference of 1.5, I can do the other thing it asks me to do, which is to find the whole definition of the arithmetic sequence. So the definition of the arithmetic sequence is going to be u sub n equals 5, because that's the first term, which we were given at the start, plus n minus 1 times the common difference, which is 3 over 2. So when you're asked to write it, fill in the formula, make sure you replace u sub 1 and the d, and then you can just simplify to get the simplified version of the formula. And then this is a really common IB exam type question. Here they gave us the second term of an arithmetic sequence. Okay, so the second term is 1, and they gave us the 7th term. So they're giving us 2 random terms. They are not giving us the first term this time. So now we don't know the common difference, d, and we don't know the first term, which is u sub 1. So in this case, we're going to actually have to use a system of equations, and I'll show you what I mean here. I'm starting with the formula for an arithmetic sequence. When in doubt, start there. I know the second term is 1. So you can see the first thing I'm doing is replacing this n and this u sub n with second term, value is 1. The other thing I know is that the 7th term is 26. So I'm going to write a second equation where the 7th term is 26. Notice that both of these equations have 2 variables in them. I do not know u sub 1, right? For this sequence, I just don't know the first term. And I do not know d. I do not know the common difference. But I do have 2 equations that I can use. An equation based on the first piece of information and an equation based on the second. When I have 2 equations with 2 missing pieces of information, like 2 variables, I can solve it using a system, like the elimination method, for example. So the first thing I'm going to do is simplify both of these. Okay, so I'm going to simplify the first one to just 1 equals u sub 1 plus d. I did that by actually subtracting, right? 2 minus 1 is just 1. So I can just write this as 1d. And the second equation is 26 equals u sub 1 plus 6d. Where did 6 come from? By doing 7 minus 1. And then I'm going to solve it using the elimination method. If I put a subtraction sign in front of the second equation, I can just eliminate the u sub 1s and then add these 2 equations together. This is just the elimination method for solving a system of equations. This is something separate that you can review if you're not sure what I'm doing. But I've seen you guys evaluate systems of equations before. I have confidence in your ability to do this. So if I eliminated u sub 1, I'm now solving for d, and I figured out that d, the common difference, is 5. Now, knowing that the common difference is 5, I can plug that back in to figure out what my first term is. So I'm going to plug it back in. You can plug it into any equation that you wrote so far for this problem. So I'm just going to plug it into my first equation that I wrote, plugging in 5 for d and solving the equation for u sub 1. So now I know first term is -4, common difference is 5. And what else did it ask us to do? Find the 100th term. So if I want to find the 100th term, I'm going to start with my formula, right? I'm going to fill in my first term and my common difference, which I now know. And then I can plug in 100 for the term number and figure out that the value of the 100th term is 491. That is all for this lesson.